Here's what we're doing. We are doing group presentations on these 7 problems. Okay? So I'm going to let you discuss for about 15 minutes. At that point, I'm going to assign each one of your groups one of these problems. Okay, I'll give you another few minutes to make sure you have it written down. You have somebody to explain how to do it. And then you're going to record on the iPad and explain your answer. Okay?
Do you want me to read the whole? Okay. The figure shows a bridge arching over the Laconic Parkway. To accommodate the road beneath the arc is 100 feet wide at its base, 20 feet high at the center, and parabolic in shape. The arch can be described by y equals kx parentheses k or x minus 100 if the origin is placed at the left end of the arch. Find the value of the coefficient k that makes the equation fit the arch. Okay. So I just wrote it down there, and I plugged these in there.
Why did you plug those in there?
Because x is 50, right there. And
why is x 50?
because it's right there. Because it's halfway between the 100.
Okay, so 100.
And y is 20 because it's 20 feet high. And so I multiplied that by that, and I combined those. It gave me 50k times negative 50. So I multiplied these two together and got negative 2500k, and divided that on both sides, which gave me k equals negative 0.008.
Is it possible to move a rectangular object that is 40 feet wide and 16.5 feet high, a wide trailer, for example, through the opening? Explain. Well, we plugged in negative 1.25, or negative 1 over 125 into the equation of y equals kx times x minus 100. We plugged that in for k because we discovered k in the other question. So we used the coordinates 50, 20, and plugged them 20 in for x and 50 in for x and 20 in for y. And so plug that in and just, never mind, that was for a different one. But we found out that the dimension of it was 40. So that means, and the halfway was 50, so that means that plus 20 was 70, and the 50 minus 20 is 30. So since we wanted to figure out if we could fit it in, we just plugged in 30 for x, because that was an x coordinate. So we plugged that in, and we got y equals 16.8, so the trailer could barely fit through.
Is there a unique parabola whose symmetric axis is a parallel to the y-axis and passes through 3 points, 1, 1, negative 2, and 0, negative 4? Write an equation for it. Given that any 3 points must be a parabola that will pass through them. Explain. Okay. The equation for it is y equals ax squared plus bx plus c, and we plugged in 0, negative 4 for c, negative 4 for c, and then we'd use negative 2 for x and y, so we got negative 2.
Why'd you plug in negative 4 for c?
Negative 4 in for c is because there's a 0 for the y, so we just put it in, and we got negative. And we plugged in negative 2 in for y and x, and we got negative 2 equals a times negative 2 squared plus b times negative 2 minus 4, and we get negative 2 equals 4a plus minus 2b minus 4, and we added 4 to both sides, and we get 2 equals 4a plus negative 2b, and then we started a new equation, so we it's our new equation we got, and then we plugged in -4 back in for C. We used 1, 1 for x and y, and we got 1 equals a plus b minus 4, and we plus 4 to both sides, and we got 5 equals a plus b, and since we needed to get rid of the -2b, so we multiplied each side by 2, and we get 10 equals 2a plus 2b, and we subtracted both the equations to get 12 equals 6a, and then 6 divided by 12 equals 2a. And we went back to one of our original equations, 5 equals a plus b, and we plugged in to a for 2 for a, and we get b equals 3. And then we plug all that back into the equation to get y equals 2x squared plus 3x minus 4.
Alright, so we start off the problem, well, you have to write it. Then we establish a common denominator. That would be 3x, so we touch. So they know what you're talking about. That's what I'm talking about right there. The common denominator is 3. You have to establish is 3x, so you multiply the right side by 3 and the left side by x. Once you establish that, you plug all those in to the left side and the right side, you get x squared plus x over 3x and 3x minus 3 over 3x. Okay, I hope that's right. Then you combine them, and you get x squared plus 4x minus 3 over 3x. That is equivalent to 2 over 1. But because we have to find x, we're going to need to isolate it in a way that'll give us the answer. So we cross multiplied both sides because they are equal to each other, and we can do that. And we get 6x is equivalent to x squared plus 4x minus 3. Now we're going to set it equal to 0. So we need to subtract 6x. And we end up with x squared minus 2x minus 3 is equivalent to 0. Then you FOIL it out, get x minus 3 and x plus 1 in parentheses. And your final answer, once you take it out, because this should still be equal to 0, is going to be 3 and -1. And you plug those in, and you will get 2.
Okay, so what is the distance from point 4, 2 to the point -3, -2? So pretty much I just drew the little triangle thingy here. So I just counted, like down here, that it's 4. It's 4 units down and 7 units over, or -7 units over, whatever you want to do. But so I just calculated that, so this is kind of like what I got right here. So you got the point, this point over here, and that point over there, and you subtract those 2 points, and then you get 7, 4. Then you take then you square both of those two. So you got 7 squared plus 4 squared, and so that is equal to 49 plus 16, which is 65, and then the square root of that is 8.06. So that's pretty much the distance. That's what I did.
To get from one corner of a rectangular court to the diagonal opposite corner by walking along two sides, a distance of 160 meters must be covered. By going diagonally across the court, 40 meters are saved. Find the dimensions of the court to the nearest centimeter. So it says the distance from here to here is also equal, when you walk these two sides right here, would be 160. And it says that this angle right here is 40 less than 160, so obviously that's 120. And to do that, you have to get a squared plus b squared is equal to 120 because that formula. And to find x, you have to plug in x to the this formula right here. So this side is x, and this side is 160 minus x. So you get x squared for a plus 160 minus x squared. And that's equal to 14,400 because 120 squared is 14,400. And when you solve all this out, you get 2x squared subtract 320x plus 25,600. And you have to get this side equal to 0, so you subtract 14,400 from 25,600. And you get 2x squared subtract 320x plus 11,200 is equal to 0. And you have to plug that into the calculator, which I did here. And I got, then you have to find this, or one of the x-intercepts. And the one that I found was x is equal to 51.72. And that is, which is equal to x. So then to find the second one, you have to subtract x from 160. So you get 160 minus 51.72 is 108.28, which is equal to the longer x.
How did you know which of the intersections to take?
I don't think it mattered, did it?
It doesn't. So what would the other intersection be?
It would have been 108.28.
Perfect. Go ahead and stop that. So a mathematics teacher wants to make up a quadratic equation, ax squared plus bx plus c equals 0, so that a, b, and c are integers. The correct solutions are x equals 1/2 and x equals -3. Find the values for a, b, and c that will do the job. Is there more than one equation that will work? So first of all, understand that factors are solutions to quadratics, and in fact, they're solutions to any functions. Okay, so that equals 0. So here, I just said, okay, x equals 1/2. So one of my factors is x equals -1/2, or x minus 1/2. X equals -3 is another solution, so their factor would be x plus 3. Those have to multiply to equal 0. Okay, so I just distributed this out. X squared, 3x, minus 1/2x, minus 3/2, which is 1/2, equals 0. Combine like terms. Well, this is an answer that would work for an equation, but we want a, b, and c to be integers, and 5/2 is not an integer, -3/2 isn't. So I multiplied that by 2 and got our answer here of 2x squared plus 5x minus 3 equals 0. Another way you could do it, this is our way number 2, is that remember that either one of these has to equal 0, and both of them have to equal 0. That's why this works. So when I make x plus 3 equal to 0, x equals -3. So I actually made this factor different, but do you see how if I set this factor equal to 0, so if I did 2x minus 1 equals 0, I solve that for x, I get 2x equals 1, x equals 1/2. So that's another way you could use your factors and keep whole numbers the whole time without using fractions. Okay? So you can kind of see what, since we have x equals 1/2, notice where I use the 2 and the 1 there. And then when I distributed it out, I still get the same answer. Now last part, it says, is there more than one equation that will work? Yes. Yes, there is. I can use, well, here's an example. If I had a factor that looked like this, I solve that for x, what would I get? X equals -3, right? If I solve 2x plus 6 equals 0, x will equal -3. So that still gives me an x equals -3, right? I could do the same thing for the other one. Or I could just leave it the same, 2x minus 1. If I multiply this out, I would get 4x squared plus 10x minus 6. How is that similar, or how does that compare to my other answer? Yes? Yeah, that's just the first one times 2. So any multiple of this one will work as an answer.